Hey guys, in this lesson today that we're going to do in 10.2, we're going to be using a new operation that you may or may not have seen before, and it's called factorial notation, or sometimes we just call this factorials for short. So before we get too far into the content of 10.2, which talks about permutations, we'll talk about that in the next video, I just wanted to focus this first intro video on what a factorial is and how you write it and how you reason with it, because it introduces it in the book very quickly, and I think maybe just kind of wrapping your mind around what that means first is a better strategy. So factorial, these are all factorials, and you'll notice there's a lot of these exclamation points. Let's start off with something that we know. So this is 5 to the 4th. Now this is not a factorial. The reason why I put this on here is because this represents a product. Okay, it represents repeated multiplication, and what we know is this is multiply 5 by itself 4 times, or we need 5 copies of 4 all multiplied. So we got 5 times 5 times 5 times 5, which is going to be a pretty big number, right? 5 times 5 is 25, times another 5 is 125. And then 125 times 5 is another higher number. Let me see if I can get it here. Alright, so 625. Okay, so that's nothing new. That's not a factorial, that's just a regular old power. The reason why I bring that up is because this represents a product, okay? And similarly, this represents a product as well. So what we can do with this is we can kind of expand it out, right? We can write it like this. This is the meaning of it, and then we can kind of figure out what that number is. Or we can use a calculator. This right here is a product as well. And what this represents, this how you say this is 5 factorial. Now this kind of looks like 5, right? Like it's like 5 with an exclamation point in it. So it seems like you should be emphasizing 5 because this is how we use this in English. But in mathematics, we say 5 factorial, okay? And this represents a product. And what it represents is 5 times 4 times 3 times 2 times 1. So it's a product. You can expand it out just like we can do up here, okay? But what it means is start with 5 and multiply it by all the integers that are below it until you get all the way down to 1. 5 times 4 times 3 times 2 times 1. Okay, and we can figure out what this is. 5 times 4 is 20, right? Times 3 is 60. Times 2 is 120. Times 1 is 120. Okay? So that's what 5 factorial, this is how you expand it, and this is what it's equal to. Okay? So 3 factorial, same kind of idea. 3 factorial is a product. We can expand 3 factorial. And we just take 3, we start with the number 3, and then we just multiply it, kind of count down from 3, 3, 2, 1, but we're multiplying all the way. So this is the expansion of this, expand it out. And 3 times 2 is 6, and 6 times 1 is 6, so the 3 factorial is 6, okay? Now depending on your calculator, you may have a factorial button on your calculator. So this is one of mine from my class set. If you have one like this or one that's similar, you can look around and see if there's a factorial button. So I'm going to get close in here. So you can see that. And then right above my power button on this one, you see there's like X with like a exclamation point. So that's my factorial button. So I could do something like, I could punch in 5, and then I could go shift factorial. So I'll show you that real quick. And you get that little 5 exclamation point, it equals, and you get 120. So you don't have to have a calculator that does that, but it might be helpful if you do have a scientific calculator to find out where that button is. You can use Desmos. They have a scientific calculator in Desmos that you can use, or you can use other online calculators if you don't have one. And you can expand it out if you don't have a factorial button. Okay, 8 factorial is going to be pretty big, but the expansion of it is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So just like with powers, these numbers can get pretty big pretty quick. So I'm going to figure out what that is using my factorial button. So we're going to go 8 factorial, so something like this. You can see that? Okay. and that's a pretty big number. 40,320. But you could also get that number by going 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Same number, right? Okay, so 40,320. Okay, now 0 factorial is kind of a weird one, and it's similar to like the power of 0. So if you recall, if we had like 5 to the 0 power, that was 1, and 10 to the 0 power, that was 1, or e to the 0 power, that's 1. Anything to the 0 power is 1. For a similar reason, 0 factorial is equal to 1. Okay? Now you might be thinking, that's crazy, because 0 times 0 is 0. Well, if you think about what's happening here, let's look at a couple examples here. Well, let's add a 4 factorial in here real quick. So 4 factorial, not one of our problems here, but it would be 4 times 3 times 2 times 1. So if you think about what's happening, every time we go down the chain, we're dividing, basically. We're dividing by like the previous number. So this divided by 5 is this, and this divided by 4 is this, and this divided by 3 would give us 2. That would be 2 factorial. And that divided by 1 would be 1. Or sorry, that divided would be 1 factorial would be 1, and then you divide that by 1 and you get 1 factorial. So the reason why this is 1 and not 0, another like way to go thinking about it is, if you recall, the multiplicative identity is 1. So when everything cancels out, when you divide everything out, you end up with 1 and not 0. So 0 factorial is 1, and you just got to kind of remember that one. Okay, another thing you're going to see is dividing factorials. Okay, now you can find out what 8 factorial is and then find out what 5 factorial is and divide them and simplify, but there's actually a much easier way to do this. If you expand it out, you can actually see what's going to cancel here. So 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. Okay? So if you have those expanded, you can see that there's a bunch of stuff that's going to cancel, right? Like this 5 is going to cancel with this 5, and this 4 is going to cancel with this 4. Basically, anything below 6 is going to get canceled. So really what you have here is 8 times 7 times 6. So one way to go about simplifying a division with factorials, which you're going to have to do a lot in the next few sections of the textbook, is you're like starting here and you're going to end here, right? So it's like 8, 7, 6. Everything after 6 you're going to cancel out. So this right here is the same thing as 8 times 7 times 6. So let's figure out what that is real quick. Okay, so that's 336. Let's do one more example of that real quick. We'll do 10 factorial divided by 6 factorial. Now, if you once you get good at this, you can kind of be like, well, that's just 10 times 9 times 8 times 7. Okay, we know that we're going to go 10, 9, 8, 7. We're going to count down because that's what factorials do. But we're going to stop after 7 because 6 and everything else below 6 is going to get canceled. So this is what we're going to end up with. Now, just to write it out, just so you can see it again, 10 factorial, if we expand it all the way, is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Right? But again, the 6's are going to cancel, the 5's are going to cancel, the 4's are going to cancel, the 3's, the 2's, the 1's, all the way down the line. And so this is why, this is what we end up with. So there's a couple ways to think about this, right? Expand it all the way out and cancel, or you can think to yourself, okay, start at 10, count down, multiplying 9, 8, 7, and then as soon as you get to 6, stop. Or stop after 7, basically. So put the 7 down and then 6 and everything else is gone. So that's just a brief intro to factorials. You're going to see these a lot, so I just wanted to kind of write those out and give you a few more examples than there were in the book. But again, they're just products. They represent multiplication. You can expand them out and see the meaning of it.